again, the very general idea is that you've started a pattern, and you're looking at the pattern being repeated over and over and over again, and searching to see if there is some final result. That's how you want to think about limits in general. So for this particular example, we're working with this function. It's actually that same function we had in an earlier problem. Pi divided by x is being multiplied by sine of x. And x is going towards infinity. So the pattern that we're starting is taking x's that are kind of big and plugging in bigger and bigger x's. Again, I tend to just work with powers of 10, but the idea is you're picking any x's, and your pattern is that you keep increasing the value of x and looking to see what is happening to your, your function values. Is there some ending result that you're reaching? Okay, so my pattern is you keep increasing x. Okay, so I keep increasing x. So I take an x, I plug it in, see what I get. I then take a bigger x, I plug it in, I see what I get. I then take a bigger x, I plug it in, I see what I get. The graph here is sort of showing us what's happening. As you plug in bigger and bigger values of x, the waves are getting shorter and shorter and shorter. The reason why is that this term here, which is actually the amplitude of my wave, okay, the amplitude of the wave is what multiplies the wave function. So as x gets bigger, pi divided by x is getting smaller. And so, because the amplitude keeps getting smaller and smaller and smaller, as I divide by bigger and bigger number, my waves get shorter and shorter. And if you, aside from looking at a graph, in our class, we also have the benefit of looking at our graphing calculators, which, by the way, you want to get your graphing calculator if you don't already have a graphing calculator. If you don't want to buy one, where can you go?
Library.
The library, yes. Okay, so if you are investigating this problem on your own, you either have to graph it or use your table. So okay, so I hit y equals, and I type in my function, and I'm going to look at the table because we already have the graph drawn, but if you did look at the graph, part of getting a good graph is setting the window. By the way, if the calculator is brand new to you, I know this is kind of last minute, but both last weekend and this coming weekend, there's a 1 credit hour class all about the graphing calculator. There's a little flyer on the wall over there about it. And it meets here, it's in one of the, it might be in 268, the room next door. But it's 1 credit hour, and it meets Friday, Saturday, and Sunday. Tomorrow night is when it would first meet, and then it meets Saturday and Sunday in the morning. And you go through all kinds of important stuff about the calculator. So it really would be beneficial for everybody. I meant to mention it Tuesday and I forgot, but I apologize. But you still could, at last minute, get in if you wanted to. Otherwise, I do tell you what to do. It's just, again, we've got a lot of stuff to talk about in class, and so I don't necessarily have time to troubleshoot everybody's calculator. That's when it gets to be a problem in class, is like when I do something and then you guys are trying and everybody has some different problem and I'm trying to go around. That easily could eat up by half an hour. Okay, so I've graphed it. I'm going to use the table, but think about the problem that we're doing. We're finding the limit as x goes to infinity. Okay, so when I use my table, I want to think about x is going to infinity. So I'm going to go and set up the table, so I hit second window and that went into table set. I'm going to start at some kind of big number, and I'm gonna skip by a big number. Okay, again, this little triangle means increment, so I'm incrementing by 100. And I'm starting at 100. So in the table, I can see I'm just plugging in bigger and bigger and bigger and bigger numbers. I'm skipping by 100, and I can see the Y values are getting smaller and smaller and smaller and smaller. I actually probably could have skipped by, oh, it's not gonna do that again, is it? Let's see if I can. I meant to call that in and I forgot.